This is an AQA GCSE Chemistry question, and it's based around the topics of industrial processes and aqueous chemistry. So have a go at each section, pausing as you go, and then review once you've tried to answer for yourself. Here's part A, part B, part C, and finally part D. So you can see that this is a 9-mark question in total. So let's have a look at the answers. We have got here a question about chemical cells. A student investigated the voltage produced by different chemical cells. We have the apparatus set up. Initially, we use cobalt as electrode X, record the voltage on the voltmeter, and then repeat step 1 and 2 using different metals as electrode X. Suggest 2 control variables in this investigation. Now, the first thing that we need to consider here is the independent variable is the metal we're using as electrode X, that's what we're changing, and the dependent variable is the voltage we're measuring as a result. So your control variables are going to come from all of the other things that could be kept the same. So let's take a look at some examples. We could keep the temperature of the solution the same, because changing temperature might have an impact on voltage. We could keep the concentration of the solution the same. We could keep the same ions present in the solution. We might be using copper sulfate, we might be using copper chloride, for example, but we might want to use the same ones right the way through. And we might want to keep the size of the electrodes the same. Now, you've got to pick 2 of those. If I'm being absolutely honest, I would be picking the first 2 that I've written down as the strongest answers. Moving on to part B. And we've got here some voltages. This is what happens when you put electrode X with a copper electrode. And you can see the size of the voltages. They're not in any particular order. They are varied. But we are going to use those to answer the question. We want to know what the order of reactivity is, most to least reactive, for the metals listed. Now, what I've done here, I've written the answers in, and that's worth 2 marks to get them all in the right place. But I've actually ranked them based on the voltage. The bigger the potential difference, the bigger the gap will be between the voltages of the half cells. So the bigger the overall voltage will be. Now, in terms of the marking, you get 1 mark if the top 3 of the most reactive are in the right place. You get a 2nd mark if the bottom 3 are in the right place. But the justification: the higher the voltage, the more reactive they are. That then leaves us with silver. Because the silver value is negative, that means that copper is more reactive than the silver. So we know that silver is going to go down below the copper. Moving on, which of the following pairs of metals would produce the greatest voltage when used as the electrodes in the cell? I'm going to go back to the data again, and I'm going to take a look at the comparisons that we have. I've taken the ranks, and you can see that magnesium and cobalt are 1st and 2nd ranked, nickel and cobalt are 2nd and 3rd ranked, and nickel and tin are 3rd and 4th ranked. But magnesium and tin are much further apart. There's a much greater difference in reactivity. It's for that reason that magnesium and tin is the correct answer. And finally, going to part D, hydrogen fuel cells can be used to power different forms of transport. Some diesel trains are being converted to run on hydrogen fuel cells. A newspaper article referred to these converted trains as new steam trains. Suggest why. So it's an application question, but you are basing it around science that you will have read about, that you will have learned. Here's what we're looking for. We know that if hydrogen is the fuel and we burn it, we're going to make water, because whenever you burn anything or combust anything, you combine it with oxygen, and hydrogen combined with oxygen makes H2O, water. But at the high temperature, it's given off as water vapour or steam. Therefore, newspaper article has referred to it as the new steam train. That takes us to the end of the question. Thank you for listening.